Hey there, I am Jeff Sweenor and welcome to Pro2Pro Live. So Pro2Pro is a new digital hub for this old house where pros like me can share information with pros like you. We can exchange, offer tips, give you a whole bunch of things that you may or may not have already known. And hopefully you'll get some takeaways. So we're going to open this up to some questions a little later in the show. But right now I want to introduce a special guest, Mr. Brian Sedgeley.
Hey, Jeff.
AKA Sedge.
How are you?
From Festool. Yeah, so you spent some time in the shop here.
I have. I also started in the shop down in Fort Lauderdale. I had my own cabinet shop. Did that for a few years, and then Festool came a-knocking. So I've been with Festool as a tool and application trainer for about 12 years now.
Yep.
And I travel around the country showing people how to use the tools and the right applications for the tools.
Right. So let me just tell you about Sweenor Builders. We've been in business for 30 years. We built over 300 houses, most of which we frame ourselves. So we're constantly trying to improve our efficiencies and improve the way we frame houses. So we've developed a system that we can do right here in the shop on a day like today when it's pouring, or we can bring it out into the field. We could do it in a garage or another house that we're building. And that way we've got a system here where we can have some things going on outside of the actual frame. They're pouring the foundation still, so we can start putting some things together, and it makes a nice, easy way to transition into the job.
Sure.
So let me show you what we got going on here. So we designed this house. We've got an in-house architectural team, and they have drawn this house, designed this house. It's in Narragansett. It's up out of the floodplain. So we create this in AutoCAD, and that enables us to convert it into a couple of different formats. One is a program called Revit, and the second one is a new program that we're unleashing, and I think you're looking at that now. It's Lumion. So that really gives a real-life digital imagery. It's almost a photograph before the shovel even goes in the ground. So it's a real powerful tool for the customer. So this house right here, you'll see we've got a lot of window systems here. Sure. Now, the whole premise of this is we want our headers to all line up. We've got 8-foot doors, and we've got windows that flank it. So we want to have all our headers across the entire house be at that 8 foot. So we can control that. With that system in Revit, we can break out some individual shop drawings which are going to get us to those modules. So you can see here, we've got our header height called out, our reference line, and that's at 8 foot. So everything is based on that, and then we can then calculate our wall height. So when we do our wall heights, we want to factor in our height limitation of the entire house, but we also want to factor our drywall. So drywall comes 54 inches. So we want to make sure that we can put 2 pieces of 54-inch drywall on there, and we don't have to cut
Makes sense.
to make that. So this shop drawing also comes with a material cut list. So each window location, this is assembly A, and each one of these has a cut sheet here. So Adam knows exactly where to pull the stock from. He's got the lengths so that we minimize waste. He shows you the insulation pieces, the headers, the subplates, all of the different components here. We can cut it out, and then we've got our own labeling system. So we can label all these components. Anyone in our company can take this and build this system, and it'll be exactly the same.
Well, that keeps it simple.
Yeah.
For sure.
So this station right here, we've got a lot of cross-cutting. So we've got all of our header stock to cross-cut. The tool of choice for us for this is the HK55.
So I just want to point out a couple of things while I'm here, give you a couple of tips and tricks so you maybe make it a little more efficient for you.
Sure.
All the cuts today on this rough opening is all 90 degrees, I believe, right? Okay, so when you have a choice, like this would be the choice for the job site. This is battery powered.
Right.
Okay, but we're working in a shop today, and Adam's going to be using our dust extraction with the HK. But a couple things to point out about it is it's basically having a speed square attached to your track saw. All right, so I'm going to take this off. It comes with this length here of track. This gives you about a 16-inch crosscut capacity at 90. But we have them in shorter rails, and that's what Adam's going to be using today. This will give you about a 9.5-inch, but we also have one that will give you about a 27-inch crosscut capacity. So what's nice about that is you can gang a lot of boards together. Sure. Okay, keep it easy.
Yeah.
So when we look at this track, it's basically a spring, and you have a retraction system here. But you see how you guys have it had 0?
Yep.
If we look at the bottom here, this is the fixed point, and I call this the variable point. So when we line that up and say this is our cut line, we'll bring that right in with those 2 points and get a perfect 90 degree, because we have it at 0.
Right. The other thing I like about it is when we measure, we make one tick mark with our pencil there, you put that guide on the tick mark, and away you go. It's right on the money.
Absolutely.
That's what gives us, so we talk about headers, right? I go to the job site sometimes, I see gaps in the headers, a little bit moved, one's a little bit longer than the other. With this, we get accuracy, accuracy, accuracy. I could go look at our window assembly and say, that's money right there.
You know it. Takes that rough carpentry, which we always call framing, to a little better accuracy.
So you mentioned the cordless. You know, we bring the cordless one to the job. I mean, let's bring the saw to the work rather than the work to the saw. So in the shop, we got the luxury of the cords, the power, and the dust extraction. It makes for a neater shop, and
for sure,
you know, we'll go. So let's give this thing a whirl.
You bet.
So Adam, what do we got? We got a header for this window assembly.
LVL, making a simple crosscut, cutting it down to size.
Perfectly square.
Jeff, one more thing, and Adam, one more thing I want to point out, and you guys already have it on the saw, is the blade that comes with it is an 18-tooth blade.
Right.
When you're doing all these LVLs and all these 2x materials,
right,
what I always do is I switch it out right away, and you guys did that as well. I put the 12-tooth blade on there, less resistance, less teeth in the cut, less resistance.
Right, right. Yeah, that's awesome.
Yeah.
So let me show you the next station where we build our headers. So we have the opportunity to build insulated headers. Okay, so what's going to happen there is we've got a 2-inch rigid insulation, which is going to incorporate into our header system. Okay, we only need 3.5 inches of header. We've got a 5.5-inch wall. Okay, so that gives us the opportunity to add some insulation, add some R value to that wall system. Now, there's a couple ways to do it. You can put the insulation on the outside, which the building science people really like because we got a thermal barrier, okay? The problem is we use AZEK pre-made window header kits that we build in the shop here. So we want to drive our AZEK Cortex screws into that top header. When you hit this, doesn't grab.
No.
So we can't do it on the outside. Then the option is you put it on the inside. The problem there is we've got these nice poplar head casings with crown molding on top, and we've got no fastening ability on top of that. So what we're going to do is we're going to actually sandwich it, and we're going to put it in between. Now, the engineers sometimes don't like this because you don't really have the effect of the double member there because they're independent. They want to roll. So we solve that by we put a top plate on top of that header, we put a bottom plate on top of that header. Now we've got a true structural header with insulation in the middle there. That'll give us R10 in this assembly.
Oh, wow. Makes it really strong, too.
Yeah. Now, we've been trying to figure out for years how to cut this rigid insulation. A utility knife, the long blades, all of these types of systems, and it's just not right until we found the track saw. Works perfectly for that.
Yeah.
So Riley's he's cutting our lengths, so you'll notice that we need specific lengths and specific widths. So this is a 7.25-inch microlam. We want 7.25-inch insulation. So as you know, we put the tick mark and line up that track, and it's dead on each time.
Dead on, for sure.
So let's see how this goes. Sedge, that's better than the factory edge.
Now, I want to point out, we're cutting that inside, and let me ask you this, does that create a lot of dust?
Oh yeah, it's nasty.
And if we look at this, so we're using the TS75 today.
Yep.
we have a TS55 which cuts 1 15/16. This is 2 inch, so that's why we want the 75. You could probably cut this with the 55. The nice thing is we combine that with the hose, and we're getting the lion's share of the dust.
Right, right.
And I mean, you guys have probably been doing this you could do it with a regular saw, a regular circ saw.
Yeah.
But once again, you have to jump through the hoops.
Right.
Riley measured this.
Right.
At what, 7 1/4?
Yeah.
Okay. He made his witness marks, his tick marks, and wherever you lay that guide rail, it cuts right on that line. Whether we cut it at 90 degrees or anywhere between 0 and 45.
Right.
It's not like trying to measure from the side of the saw, which we used to do, that 1 1/4, that offset, lay a straight edge down, and you're balancing that saw up against there.
Yeah, yeah.
Okay? This, you get everything with it. You just lay it right down and you're ready to go.
Right. One of the things that we really like with that saw, we do a lot of tapered columns.
Oh, yeah.
Okay, the long tapered columns, and that's just kind of the look of the houses that we build. We like to do them out of PVC because it's the best material for the job. But how do you do an angle cut and a bevel at the same time? The track saw hits it on the money.
And it saves so much daggone time, don't it?
Right, yeah.
Sure.
We use it a lot. We like it a lot.
Yeah.
So this wall, this header for this wall is labeled, and now it's ready to go into its assembly spot over here. So let me show you where we work.
Cool.
So
that's the C
yeah,
and the plans.
that's right. So
And everything's labeled.
we got this table, we combine 2 tables together, and this becomes our workstation for our shop environment for this thing. So last thing we've got to do for this window assembly is drop this header into place, and that thing's just going to slide right in. We fasten that, and here's our wall unit. So let me show you the components. So as I showed you with that drawing, we've got this window assembly. We've got a bottom plate and a top plate. Now these are sub plates. So we've got an actual bottom plate and a top plate at the job as well.
Gotcha.
So we cut everything 3 inches shorter so that we can put this bottom plate and this top plate on this one module. So the reason for that is it gives us the ability to make a square and an efficient box to transport. So we'll mark the center on this, and at the bottom, when we get to the job site and we lay out our wall and I make my center mark for that window, this assembly drops right in. We line the center and the center. You stand it up, it's plumb level square, and it is accurate.
It's like a no-brainer.
Right, right. And
Wow.
you know, that's the componentry we have. And anybody, like I said, in our company can put this together because it's all labeled. Everything is labeled. You got your studs, your jack studs, your cripples, your sills.
Wow.
So the cripples we'll actually pre-cut, but we won't install them at this point because when we get to the job, we lay out the wall. We want to put our cripples in on layout.
Yeah.
So that's, you know, that's the way that works. And then let me show you another thing that we've got here with the way we do our windows.
Oh, that's cool. Is that typical siding?
This is just a piece of beveled clapboard. You see it's thicker here and it's narrow here. This is a Tom Silva trick.
No kid.
Oh yeah. So we put our sheathing down onto this opening first, right? This is still on the deck. We router out the opening. That way we get a perfect crisp line around there. Cool. So now for our windows trick, we want to put the thicker part of the bevel, right? The thicker part we want on the inboard side.
Right.
Okay, so everything is tapered outside. So that gives us about a 5-degree bevel. So, and then on top of that, we're going to use our butyl stretch tape.
Oh yeah.
Okay, and then any water that gets in that window assembly will come into this pan and it pitches toward the outboard side, toward the exterior.
That's a pretty cool trick, huh?
Yeah, Tom Silva.
Wow.
So let me show you another thing that we do that really, I like it a lot. It saves us a lot of time. So in a wall system, right, we've got these places where an intersecting interior wall will come, okay? So we got an outside wall, which is 2x6, but we've got an intersecting 2x4 wall for interior walls.
Yep.
So this pocket is really difficult to insulate. There's a couple of ways to do it, you know, and a lot of times you put blocks in so you leave room. The insulators sometimes forget it, and you've got this cold pocket here. So what we've done, because that track saw is so accurate, we can rip this foam, this styrofoam insulation into 3.5-inch strips. So we've got 2 of them in there. Now we've got a solid R20 wall pocket. I mean, that's pretty darn good.
That is good.
So we make, there's probably a dozen of them per floor. We pre-make them, we label them, we bring them to the job site, those go in, and this reduces the time on the job a lot.
And it's not pouring down on you.
Not pouring down, it's accurate. We'll stack all these up on our big flatbed trailer, we'll strap them down, we bring it to the job. Framing the walls goes so quick when we've got all of this done.
Wow, pretty cool.
So we're going to open it up to some questions, and I know we've got plenty of them here. Wow, look at this, they're flying in here. Oh, man. Oh, geez. So for Sedge, does the HK55 cut PVC?
It does. So you know how we changed the blade, or you guys changed the blade to that 12 tooth?
Yeah.
It comes with an 18 tooth blade, but you can, and that's good.
Right.
But with PVC, I would probably go with the 32 tooth.
Sure.
And that's
a
little bit smoother, more teeth in there.
Right,
and
right.
You get a better cut with that probably on the PVC.
That's good to know, because then that joint together, we glue that with the PVC glue.
Yep.
Having that joint, tight is really nice.
Especially that outside corner
exactly,
where they meet.
where you see it.
Absolutely.
Yep. So do you install a rough opening when the wall is up? No, actually we do the rough opening with the wall down. Again, we sheath it down, we cut the openings with the plywood, and then we stand it up and it's ready for the window.
Cool.
What is the depth of cut on the HK saws?
Okay, so let's talk about the number. It says HK55.
Yeah.
Okay, so that's the depth of cut off of the guide rail, 55 millimeters.
Okay.
To an eighth.
Yep.
Okay, in imperial. But on the guide rail or the FSK rail, it's 50 millimeters or just around 2 inches.
Sure. Yeah.
So you get a nice 2-inch depth of cut.
Nice. So another question, why do we use LVLs versus conventional lumber? Great question. So as we showed over there, we've got 2 LVLs. An LVL is 1.75 inches. 2 of those equals 3.5. That leaves 2-inch gap, and that's perfect for the insulation. The other thing we like about engineered lumber is less shrinkage when we get it into a controlled environment. We get it into the house, you get a heating season through, you get a little bit of shrinkage in dimensional lumber. The engineered lumber helps to eliminate that, and we like that for the headers themselves. So, do we insulate our corners? So, we can insulate a corner very similar to the way we do this pocket. There's a couple of ways to insulate corners, and the one that we like the best is just a California corner, they call it, where you leave an opening behind there so that when we spray foam, we can actually get in behind there. As opposed to this pocket, which once that interior wall goes in, you can't get behind there.
Gotcha.
So that's an option. Do you do your doors this way too? Absolutely. So in that module, that plan set, a lot of these openings, there's a door in the middle and there's the 2 windows on either side. Sure. So we definitely do the doors the exact same way. And again, this draws back to our AutoCAD drawing. It is critical. A door comes, an Anderson door that we're going to use here is exactly 8 foot for our rough opening. That means we want 8 foot rough opening top for our window. So it's all calculated in. Let's see, what do you use for a vapor barrier? So in this particular application, so we're right on the coast. A lot of coastal driven rain, a lot of pressure differential inside and out. So we like to use a 2-inch spray foam application of closed cell. So that gives us our vapor barrier on the inside. And then we'll probably add to that, we'll add a rock wool insulation to get the rest of the R value. That gives us some sound deadening qualities. So to answer the question, we'll use closed cell on the inside for the vapor barrier. Do they frame a room at a time with drywall and then put it all together in the field? No, we actually do all the framing first, and then we do the drywall. So we're running out of time here, I can see. We got one last question here. How much time does this process save you? Well, it saves us a lot of time. Not only does it save us a lot of time, it gives us such a better control. I mean, every joint you see here is perfectly on the money. I know that that opening is exactly correct. I know it's square, I know it's level, I know it's plumb, all of those things. So when you factor that in, we get to the job and we're just dropping these modules in, the frame goes like that.
I can see where that speeds it up.
Yeah, so we're gonna have to sign off for now, and I wanna thank everybody for their interest in this operation. We're gonna do a lot of these Pro2Pro live events going forward. I want you guys to follow us on Instagram. Pro2Pro is the Instagram. Pro2Pro TOH, sorry. This Old House on Facebook. We got thisoldhouse.com, and there's a Pro2Pro newsletter. I want you guys to sign up for that, and let's get involved. Sedge, thank you for all your help.
Thank you, Jeff.
All right.
It was a pleasure being here.
Right on.
And thank you.